Okay, Algebra 2. This is part B of our semester review. In this video, I want to get done problems 18 through 32. So just this whole middle page here, front and back, that will get us through the last of chapter 6 and then chapter 7 and chapter 8. So starting with number 18, we had in the last video, we talked about like number 15 if you look at your packet. And number 15 here is kind of set up in the same way that number 18 is. I have 3 to the 4x power and 9 to the 3x plus 7 power. So 3 and 9, we noticed that I could write those as the same base, like 9 was the same thing as 3 squared. And then I could cross out the 3's, okay? But on number 18, the problem with that is, like 8 could be written as 2 to the 3rd power, but 30 can't be written as 2 to any power. Like 32 is, I think, 2 to the 5th power or something like that. So we can't write 30. So what do we do when we don't have, when we have two numbers that we can't change them to be the same number base? Well, what we can do is we can put a natural log in front of both sides. Okay. Or you can just put a log base 10 in front of both sides. Both will work the same way. So I do ln of 8 to the m plus 1 power equals ln of 30, and that's kind of what he looks like there, okay, if I rewrite him nicer. And then because now we have a log in front, this m plus 1 can come down and be m plus 1 here in front of the whole thing, okay, so the m plus 1 is no longer there. And then what that allows me to do is, this is like m plus 1 times ln of 8. So what I can do then is divide by ln of 8 on both sides. Okay, cross that out, and then I will have m plus 1 equals, that'll be ln 30 divided by ln of 8. Okay, and then I can go ahead and subtract 1 from that, not 3. Why am I saying 3? I don't know. Subtract 1 from that. Okay, so m is going to be equal to, if I plug that into my calculator, okay, he will look like, let's see, ln of 30, close parentheses, make sure you close that off, divided by ln of 8, close parentheses again, and then I'm going to go ahead and hit enter, and then I'm going to subtract 1. Okay, so my m is going to be 0.6356. We'll go 4 decimal places in that case. Okay, so that's kind of what he looks like. So because I could not write those as the same number, I would have to put a log in front of both sides or an ln in front of both sides and then solve it that way, okay? Number 19, here's my equal sign right here, so keep track of where he is located, okay? I have 2 logs on this side, and there's a plus sign in between them, okay? And in log world, a plus sign means multiply. So when I put those 2 together, he will be log base 6, but what I'm going to multiply is the 10 and the x together. So he will look like log base 6 of 10x equals log base 6 of 40. He's just chilling out on this other side, okay? And now, since there's a log on both sides, those 2 can cancel out, kind of like the 3's canceled out in number 15. Since there was a 3 on both sides, they canceled. So then I will just have 10x equals 40, okay? Dividing by 10, I just have x equals 4, okay? But the real key there was putting those 2 logs together by adding, and add actually means multiply. So you have to do that first before you cross anything out, okay? Number 20 is kind of testing your properties of logs, or ln's, and e's. E and ln will cancel each other out because they are inverse functions, but they will only cancel each other out if they are right next to each other, okay? So I have to get rid of this 5 somewhere, okay? And kind of like the m plus 1 could move down in front, now the 5 is down in front of the ln. So I can move him to the back, so this would be like 2 to the 5th power. So if I rewrite this, this would be e to the power of ln of 2 to the 5th power. That's a lot of exponents going on here, okay? But now that allows me to cancel out the e and the ln. So I just have 2 to the 5th power, and 2 times 2 times 2 times 2 5 times is just 32, okay? You can do that in your calculator if you didn't already know that. So 32, okay? 21. Now we're under rational functions. If y varies directly as x, okay? The equation for y varies directly as x is y equals k times x. They're directly related to each other. And remember that k is just a number, okay? So we have to first figure out what k is, and we're going to do that by plugging in these two numbers for x and y, okay? So if I plug in 18 for y, I'm going to do that over here, 18 goes in for y, k is what I'm trying to solve for, 3 is what x is, okay? So if I divide by 3, that will tell me what k is. K is going to be 6, okay? Now I do the problem one more time, and y will be equal to, so I can rewrite this as y equals 6 times x, because that's what our k is. So I'm just rewriting this thing with the 6 put in there. And now they want me to find y when x is 5. Okay, so y is what I'm solving for. And I'm going to plug 5 in for x. So I have 30 in this case. Y is equal to 30. Okay? All right, now we got a lot of exponent stuff going on next. We spent days and days and days on this, I remember, in class. So hopefully that kind of stuck with you a little bit. On number 22, we have, things that we're multiplying together. So we usually just multiply straight across the tops and the bottoms, but we can cancel things, that will cancel out. What I'm going to first start with doing is the numbers. I have negative 16, 15, 27, and 8. Let's start there, and let's see how we can reduce those. So the first thing that I see is negative 16 and 8. I can reduce both of them by 8. If I divide by 8, negative 16 divided by 8 is negative 2, and this 8 will become a 1, okay? And then I have 27 and 15. Both of those are divisible by 3. 27 divided by 3 is 9. 15 divided by 3 is 5. Okay, so now I'm going to do this just to make life a little easier because I already have kind of a mess there. Negative 2 times 5 is negative 10, and 9 times 1 is 9. Okay, now I'm going to go ahead and multiply the variables across the top. So x, y, z squared. I'm just going to put those together, x, y, z squared. Okay, on the bottom, I have a z and an x squared. So I'm going to have x squared z if I put those in order. Okay. Now, at this point, I'm going to cancel. You could have canceled them up here if you wanted to, but it just gets kind of messy. Brad, you need to make her be quiet. Okay, it gets kind of messy if you get to canceling too many things. So what I'm going to do is down here, I'm going to cancel them here. Okay, so I have 2 x's on the bottom and I have 1 x on the top. So that 1 x on the top is going to go away and it's going to cancel with one of these down here. So now I will only have 1 left over. Okay, then I have 1 z on the bottom and 2 z's on the top. So this z is going to cancel and make only 1 left over on the top. Okay, so let's just write what we have now. We have negative 10. There's no x up here. There is a y, and there's 1 z on the top, okay, because we canceled them out. And on the bottom, we have 9, and we have 1 x, but no z's on the bottom. So this is what he will look like as my final answer. Okay? All right, now 23. The difference between 22 and 23 was these guys were not trapped because there was no pluses or minus signs except for the negative. That's not really a minus sign, that's more of a negative 16. But none of these had pluses or minuses in between here, but these ones do. So like x plus 3, if I want to cancel him, I have to cancel an entire x plus 3. I can't just cancel like this x with this x. Those two things won't cancel out because they are trapped. Okay, so what I have to do is break stuff down and then cross them out as entire units. Okay, so if I look at these pieces here, okay, x plus 3 will not break down anymore. Okay, x minus 1 will not break down anymore. But let's look at this top piece right here, x squared minus 2x plus 1. Okay, I look and I say, what can I multiply together to give me a positive 1, but when I add them, give me a negative 2. Okay, and that's going to be x minus 1 and x minus 1. Negative 1 times negative 1 will give me positive 1, but negative 1 minus 1 will give me negative 2. Okay, on the bottom, I ask, what can I multiply to get 6 when I add them, give me 5. Okay, multiply to get 6, add to get 5. That's going to be positive 2 and positive 3. 2 times 3 is 6. 2 plus 3 is 5. And now I go through and I cancel out things. So I see an x plus 3 here and an x plus 3 here. I see an x minus 1 here and an x minus 1 here. And that's all that I can cancel. So on the top I have left over x minus 1. On the bottom I have x plus 2. And that is going to be my final answer. Okay? All right, that is when we are multiplying. So both of those problems we are multiplying, 22 and 23, but here in 24 we are adding. Okay? And adding is kind of a weird thing. When you add, you have to find a common denominator. Okay? So I'm just going to have this x chill out here and this 3 chill out here. And x minus 4 won't break down, but this x squared minus 3x minus 4, let's break him down and let's see if he will simplify a little bit. Okay, so what can I multiply to get negative 4, but when I add them give me negative 3. That would be like negative 4 and positive 1, I think. Negative 4 times 1 will give me negative 4. Negative 4 plus 1 is negative 3. Yes, that is right. Okay. Now what I want to do is I want to find a common denominator. Okay. So I look at these guys right here and I see like what do I need to include? Okay. I know that I need an x minus 4 in my denominator. Okay. So I'm going to write both pieces with an x minus 4. And I know that I need an x plus 1. Okay. And then I know that I also need an x minus 4, but I already have one, right? I don't need to rewrite him again, okay? So then I just look at my top pieces, x and 3, and I write what they need to be multiplied by, okay? So what needs to go here that he doesn't already have? So I look at his bottom and I compare this bottom to this bottom. Okay, what does he not have that he needs? Well, he has everything. So I really don't need to multiply this x by anything here. He can just stay as x. Or if you want to write it as a 1 there, you can multiply him by 1. X times 1 will just be x. It doesn't matter. Okay. And then I look at this 3. Okay. And x minus 4 is what his bottom is. So what does he need that he doesn't already have? He needs an x plus 1. Okay. Now, going back here and checking x plus 1 over x plus 1, those would cancel out. And that should give me 3 over x minus 4, which is what I had to start with. Okay. So that's kind of a way of checking to make sure you're not doing anything illegal. All right, on the top here, x times 1 is just x. This 3 I'm going to distribute through, so this will be 3x plus 3. Okay, and then I have a plus sign in between those two. So for my final answer, I have x plus 3x, which will be 4x, plus that 3 on the end there, okay, all over x minus 4 and x plus 1. That's what he is going to look like as my final answer. Okay. All right, 25, kind of the same type of thing here, except now I have an equal sign. Okay, so a little bit different. I want to make sure that all of these are written as fractions, so I'm going to put this as 2 over 1, okay? And then I'm going to write out my 3 pieces, this plus this, okay? So I have my fraction, like 10 over 3, equals 4 over x plus 2, okay? So I have like my 3 fraction bars, right? And then I'm going to look at my denominators, just like I did the top one, okay? And I have 3, an x, and 1, okay? So I know that I need a 3 and an x, okay? And really that 1 is like just multiplied by 1, which is not doing anything. So my common denominator is just going to be 3x, so I need each one of those to have a 3x in it, okay? All right, then I look at my top pieces. So I have 10, I have 4, and I have 2. And I look at those pieces and I figure out what they need multiplied by, just like we did up here, okay? So the 10 has a 3 below him. So what does he not have? If I compare that 3 to 3x, what does he not have that he needs? He needs an x. So I put an x with him, okay? This 4 had an x below him, okay? And I want to compare that to 3x. So what do I need to multiply the 4 by? He needs a 3, okay? The 2 just had 1 below him. And to change 1 to 3x, I will have to multiply by 3x, right? 3x over 3x, if those canceled, that would just give me 2. Okay, which is what I had to start with, okay? Now, the only difference between this problem and the problem up above is that since there's an equal sign, I can cross that bottom piece out, right? So all I have here is, if I multiply this through, 10 times x, which is 10x, equals 4 times 3 is 12, plus 6x. And then I just solve from there, okay? So I'm going to subtract the 6x to the other side. So I have 4x equals 12. And then divide by 4, so x equals 3, and that's what he looks like, okay? All right, next one, 26, 8x to the third over 27, and then that is to the 1/3 power, okay? Anytime I have a fraction as an exponent, that just means it's like a square root or a cubic root or a quartic root, okay? So like x to the 1/2 power just means the square root of x, right? X to the 1/2 power. So x, or something to the 1/3 power means the cubic root, okay? So I have the cubic root of 8x to the third over 27, okay? And this is actually a really nice problem because all of these come out really nicely, okay? The cubic root of 8 means what can I take times itself 3 times to get 8? Well, 2 times 2 times 2 will give me 8, so that will get rid of the 8, okay? Now what do I take times itself 3 times to get x to the third? Well, that would just be x. X times x times x would give me x to the third power. And then what do I take times itself 3 times to get 27? That would be 3. Okay, so the cubic root of 27 is 3, because 3 times 3 times 3 is 27. And this is what he will look like, okay? So anytime you have that fractional exponent, that 1/3, that means a cubic root, 1/2 means the square root, 1/4 would mean the fourth root, etc. Okay? All right, let's go to the back page. We'll finish these couple problems, and then we'll stop for this video. 27 is the last one in chapter 7, which asks for the domain and range. Okay, domain and range. Okay, this is our rational function. It's like one of those boomerangy equations. And I'm going to pinpoint this little point right here where those vertical asymptote and horizontal asymptote cross each other. That point is at the point -1, comma, +1. Okay, so those kind of play into my domain and range. Your domain is your set of x's and your range is your set of y's. Okay, so in the x direction, he will go to the right forever. Okay, that guy's going to the right forever. He will go to the left forever, but he doesn't touch every single value in between there. He doesn't ever touch this place right here. It's like he breaks apart right there. And that point is crossing the x-axis at -1. That's the x coordinate. So x is not equal to -1. It's equal to everything else, but x is not equal to -1. It's never touching -1 there, okay? All right, for y, y will go up forever. Y will go down forever, but he's never touching this little dotted line that's between here. It's like he breaks apart right there. And that part is crossing the y-axis at +1. So we would say that y is not touching, or y is not equal to 1, okay? All right, chapter 8 is all statistics, okay? So number 28, a fast food restaurant gives 25 of their customers a sample of a new milkshake, and the employees monitor their reactions, okay? Monitor their reactions as they taste it, okay? That means they're looking for facial expressions. So if somebody spits it out, they obviously don't like it, okay? The reason why they monitor their reactions rather than asking them, do you like this milkshake? Is because people might lie, right? They don't want to make this restaurant mad if they say, no, that's a really bad tasting milkshake, because, you know, they are a customer there, right? So they monitor their reactions. So if somebody makes a really stinky face, they're probably going to say, okay, they didn't like the milkshake. So is this a survey? Are they asking them something? Are they doing an experiment, or are they doing an observational study? Okay, now, we already kind of went over it's not a survey, okay, but a lot of people get these two confused, experiment versus observational study. Okay, what they are doing, even though they're giving them a milkshake, an experiment would have to be where I have a placebo group and I have a control group. So in one group I would be giving them a milkshake, in one group I would be like not giving them a milkshake or something different to drink, okay? So that's what makes it different. This is not an experiment. So even though I'm giving them a milkshake, I'm observing their facial reactions. So this is going to be an observational study, okay? All right, 29. In a study of 150 high school students, responses, 78 students said that they were happy with their class schedule. Okay, that's only about half, that kind of, 78 out of 150 liked their class schedule. Okay, so this was my sample. I sampled 150 students. Okay, now, there were more than 150 students at the school. There were 2,000 students in the school, but I don't want to survey all 2,000 of them because that's a lot of people to have to survey. So if I were to have surveyed 2,000 and they had the same results as my sample, how many approximately would say that they are happy with their class schedule? Well, 78 is a little bit more than half of 150. So I'm guessing that it's going to be a little bit more than 1,000 students, or a little bit more than half of this 2,000 that are going to say they like their class schedule. One thing that we can do, though, to figure out the exact number is I can do a proportion, okay? We had 78 out of 150, and a way of writing that is 78 over 150. Okay, 2,000 is my total number, and I don't know how many students would have said they liked their class schedule. So we can call this guy X. And then from there, we just cross multiply and divide. Okay? So if I cross multiply, 78 times 2,000, 78 times 2,000 is 156,000, okay? And that's equal to 150 times x. And then I would just solve for x, so divide by 150, and that is 1040. Okay, so we just said a little bit over 10,000, or a little bit over 1,000 are going to say that they are happy with their cost schedule, because that's a little over half, just like the 78 was. Okay. Right, 30. The number of tickets, 30 and 31 are going to have to do with the empirical rule, so I'm going to kind of do this like this so we can look at our empirical rule sheet over here. Number 30 says the number of tickets sold at a high school basketball game in a particular conference are normally distributed with a mean, that means the average. The average is 68.7. Okay, so what I'm going to do here is I'm going to make my bell curve. Okay, and we always put the average in the center here, 68.7. Okay, if I'm looking at my bell curve, that's this guy right here. Okay, 68.7. The standard deviation is 13.1. Okay, so if I add 13.1 to each of those three and subtract 13.1, okay, let's figure out what those numbers are. So 68.7 plus 13.1, okay, so this number is 81.8, okay, if I add another 13.1, that's 94.9, and add another 13.1, that is 108 exactly. Okay. Now, if I subtract, actually, they're only asking for the highest 2.5%. So I don't really even care about these numbers down below here because they're asking for the top 2.5%. What range of tickets sold represents the top 2.5%. Okay. So on our empirical rule sheet, we said that 2.4% are going to be in between this little range right here. Okay. So in between +2 and +3. And 0.1% are going to be higher than +3, okay? So this guy, if you think about this as being 0, this is +1, this is +2, this is +3. The top 2.5% is going to be everybody from the +2 on up, okay? Because that's 2.5%, 2.4 plus 0.1, 2.5%. So everybody from the +2 on up. So normally distributed number of tickets, it would be from here on up. So I would say, let's say anything over 94.9 tickets. Now I realize that you can't have 94.9 tickets, but we would probably say 95 tickets. So anything over 94.9 tickets would be a really, really popular game, right? The highest 2.5% attendance would be any number of tickets sold that was greater than 95. Okay. 31. The number of minutes it takes Phil to commute to work each day is normally distributed with a mean of, let's do this again, mean of 18.6, okay, and a standard deviation of 3.5. So let's do 1, 2, 3. So this would be +1, +2, +3. If I subtract, -1, -2, -3. Okay, let's figure out what those numbers are. So I'm going to add 3.5 3 times, starting with 18.6 plus 3.5 is 22.1. Okay, plus 3.5 is 25.6 plus 3.5 is 29.1. Okay. And then I'm going to subtract. So 18.6 minus 3.5 is 15.1 minus 3.5, 11.6, and minus 3.5 is 8.1 for this guy. Okay, so those are my numbers going across here. What percent of the time does it take between 11.6 and 21 minutes to walk to work? Okay, 11.6 is this guy right here, and 22.1 is this guy right here. So we're really looking at between the -2 and the +1. So between -2 and +1. Okay. So if I look on here, -2 is going to be this spot right here. Okay. And +1 is going to be this spot right here. So I'm really looking at these three regions, the 13.5, the 34, and this 34. Okay. Between -2, +1. So That would just be 13.5 plus 34 plus 34. Those percentages, and that's going to give me my percent of the time. 13.5 plus 34 plus 34. So 81.5% of the time, it's going to take Phil between 11.6 and 22.1 minutes to walk to work. Okay, sometimes he's lazier than that, so it takes him longer than 22 minutes. Sometimes he's really walking fast, and he's walking faster than 11.6. But 81% of the time, it's going to take him that long to walk. Okay. All right. Last one. 32. Use the following data to create a box and whisker plot. Okay. Be sure to include the 5-number summary. So our 5-number summary is going to be your minimum, your maximum. Those are my first and fifth number. Then we need a median. We need a quartile 1 and a quartile 3. Okay, so those are the 5 numbers that we need. So what I have done here is I went ahead and put these all here on a spreadsheet. All of these numbers, I typed it in. There are 28 numbers, okay, 28 numbers, and they're not in order, but by putting them on this spreadsheet like this, I can highlight this column, and then if I go A to Z like I have it here, I can go in ascending order, and that means that it's going to put them in order from smallest to largest. Descending order would be largest to smallest, so I could have done that also probably. But since I did my minimum at the top, I'm going to go ahead and put my minimum at the top. My minimum number is 29. Let's put those in order for me. And then my maximum number is 90. Okay, so I have those really easily for me. Okay, now there are 28 numbers. So the median number, the middle number, there's not going to be one exact middle number if I have 28 numbers. Okay, so what I will have here is in between my minimum number and my median number, half of 28 is 14 and 14. So there'll be 14 numbers here, 14 numbers here. So these first numbers will be the numbers 1 through 14, and these will be the numbers 15 through 28, if that makes any sense at all. There's 14 numbers here, 14 numbers here. So my median number will be a combination of the 14th and the 15th number, okay? So 14th and 15th number I can see right here. Okay, I'm going to highlight those. 14th and 15th number are 60 and 61, and when I don't have an exact middle number, I need to find the average of those two. So the exact middle of 60 and 61, if you want to add them together and divide by 2, you can, but halfway between 60 and 61 is 60.5, okay? All right, now what I'm going to do is to find the first quarter. I'm looking at these 14 numbers, okay, and the first quarter is going to be halfway in between those first 14 numbers, okay? So if I'm looking at the 14 numbers here, okay, that means they're split up 7 and 7. So these would be the numbers 1 through 7, and these would be the numbers 8 through 14, okay? And just kind of like 28 didn't have an exact middle number, 14 is not going to have an exact middle number either. It's going to be the average of the 7th and the 8th number, okay? So 7th and the 8th number are going to be these two, and if I find the average of those two, 47 and 50, I'm going to go ahead and add those together. 47 plus 50, and I divide that by 2. That's going to be 48.5. It's going to be my first quarter number, 48.5, okay? Now I did the same thing here for my third quarter. There's 14 numbers there, so it's between the 7th and the 8th number. I'm going to count from the bottom. So 1, 2, 3, 4, 5, 6, 7, and 8 would be those two numbers, okay? So I'm averaging 70 and 74 together, okay? The exact middle of 70 and 74, if you want to add those together and divide by 2, you sure can, but that should be 72. It's exactly between 70 and 74, okay? So now I have my 5-number summary, and then what I'm going to do is make my box and whisker plot, okay? So I'm going to first make my number line here, okay? And that number line, let me full screen this here now that we have all our numbers, okay? So I'm gonna make my number line down here at the bottom, and my smallest number is 29, and my largest number is 90. So let's go from like 20 to, let's go 100. 20 to 100 is a really nice scale, okay? Halfway between 20 and 100, if you average those together, this number would be 60. So I could do, and then halfway between 20 and 60 would be 40. Halfway between 60 and 100 is 80. So that makes it really nice. And there's my numbers. Okay, this would be 30, this would be 50, this would be 70, this would be 90. That comes out really nice. Okay. All right, now I'm going to put my 5-number summary on there. So my minimum number is 29, and if this is 30, 29 would be this spot just to the left there, okay? I'm going to do my maximum number is 90, so just right on that dot there, okay? Then I have my median number is 60.5, so just ever so slightly larger than that, and that's going to be the middle of my box. Then I have 72, just a little bit to the right of 70, and 48.5, so not quite 50, right there. This is what this guy looks like, okay? And for the most part, this looks pretty evenly distributed, like it's pretty symmetric, okay? So I would say that this guy is normally distributed or symmetric. Okay, he's pretty well even and balanced on both sides. Okay, all right, so we'll stop there. We'll pick up a 33 in the next video and finish to the end.